Okay, class, I'm now ready to start 10.3, which is on compound interest. Compound interest basically means your simple interest is making interest, which you are then making money on. So it's compounding. The growth is growing. Compound interest is much more commonly used. The formula is more complicated. It is A is equal to P times 1 plus R over N to the power of NT. Whoa, that's a lot. So A is the ending balance. P is the amount borrowed or saved. In other words, the initial balance. R is the interest rate as a decimal. And N is how often it compounds each period, typically a year. T is equal to the time in years, typically. And so NT would be the total number of compounding. So let me give you some examples for N. N will be 1 if compounds once a year. They call that compounding annually. N will equal 2 if it compounds, they call it semi-annually, twice a year. Semi-annually. Ran out of room there, so I'm just abbreviating. N is equal to 4 if it compounds quarterly. There's 4 quarters in a year, just like there's 4 quarters in a dollar. And then N would equal 12 if monthly, 52 if weekly, and 360 if daily. They use the banker's rule on these, 360 if daily, unless they tell you otherwise. But typically, they don't do problems with daily. So I'm going to give you an example. We're going to use the formula, and I'm going to do a couple things with that, and then I'm going to end this video and show you another way to do it using your handy dandy pocket calculator. I'm going to do the exact same problems when we get to the calculator. So you can watch this, not take too many notes if you don't want to. Just follow my notes that I sent you, and then I'm going to show you an easier way. So I'm going to do uh, 2 children that have a grandparent who left them $25,000 in a trust that they get on their 25th birthday. So this is a wealthy grandma, apparently, and she has written a trust. And the fact that those are both 25s is just purely coincidence, or maybe it was kind of their grandmother's idea of a joke. So she's leaving them 25,000, and she's spending it on the trust for her 25th birthday. The 2 sisters are Julianne and Mary Beth. Now, Julianne, this is terrible. She's the fun-loving one. She likes to have a good time, and she takes her $25,000 and spends a year in Europe. Probably ends up coming back before the year's out. That's probably not enough money to last her a year, but she spends it. Mary Beth, on the other hand, she takes her 25,000 and invests it in the stock market. No, we don't want to talk about the stock market right now. It's very bad. But the stock market typically can earn approximately 8% annually, and I'm going to have that it compounds quarterly. And she leaves it there. They're 25 years old, and she leaves it there for 40 years. So in 40 years, Julianne will have lovely memories of Paris. Hopefully, she doesn't go when COVID hits and she can't get around, has to come back to our country. But Mary Beth has invested hers for 40 years. how much will she have? So A is equal to P times 1 plus R over N to the NT. So let's put the numbers in. So P is the amount that she puts away. That's the $25,000. She decides not to spend it, she just puts it away. Her rate is 8%. That's not an unusual rate for a stock market to earn over time. She's going to check on it quarterly, so that's a 4. And then this is 4 times 40. Okay, so the reason this is 4 times 40 is it's compounding every quarter for 40 years. So it's compounding 160 times. So now we can put that into the handy dandy pocket calculator. I don't know if you can see that on the screen there, but you can do it on yours, and I'll kind of do it on mine. It'll go in like this. I'll show you. It goes in exactly like this. You have to use the parentheses. So you got 25,000. And be sure you count your zeros. I almost put in 2,500. And then 1 plus 0.08 divided by 4. Close the parenthesis, hit the exponent key, and then put 4 times 40 in the exponent. Be sure that both the 4 and the 40 are in the exponent. If you have the older version of the calculator, it's going to take an exponent of 4 and then multiply the answer by 40. So if you did it correctly on your calculator, you should have got an answer of $594,247.67. So notice that Julianne had a great year, enjoyed her time in maybe 6 months in France, but Mary Beth put her money away, and now at age 65, she's got almost $600,000 in her retirement account. Now, of course, the stock market's not guaranteed, but that's just an illustrated example. I've had times where the stock market has grown more than 8%, and times where it's grown less than 8%, and times when it has declined. All right, so, but on average, my stocks probably grew an average of 8%. All right, so that would be an example of how to use the money. So let's say then that the same thing, if we were doing the same problem, it was compounded monthly, by the way, the only thing that would change is there would be a 12 here for N and a 12 here for N. If it was compounding quarterly, that's where I used the 4. If it was compounding semi-annually, I would have used a 2. Everything else would have changed. All right? So the second kind of questions they ask is how much do you need now to have some money for later? So Mary Beth showed Julianne one big mistake she was making, and Julianne said, all right, all right, all right, but you're not me, and I don't want to save all the money. I want to spend some of it. So she says to herself, how much should I save now? I should use the word invest because it really isn't a saving. Invest now if I want to have 400,000 when I turn 65, which is basically in 40 years. So here the problem is going to look basically the same. A is equal to P times 1 plus R over N to the NT. And so it's the same situation, only Julianne wants A to be 400,000. She doesn't feel she needs the 594,000. So the question is, how much should she invest now? These numbers are still the same. So now, in order to solve for P, she's going to divide by that. So she's going to have 400,000. Count your zeros when you put that in, and you're going to divide by 1 plus 0.08 over 4 to the power of 4 times 40. Now you better remember to put that in parentheses or it'll do it wrong. Let's see. We've got 400,000. We put that in. We divide that by parenthesis 1 plus 0.08 divided by 4. By the way, what that's doing is it's saying, hey, if you're making 8% a year, you're making 2% a quarter. 0.08 divided by 4. And then your power is 4 times 40, and she needs to put away $16,820, $828 right now. So that means if she wants to do that, she can take her money, put away the $16,828, and she can go ahead and do a vacation. And she's got $8,171, actually $72 if I round it. She can spend that amount of money on her vacation now. So she probably won't be able to go to France, but she might be able to have a pretty nice time. Okay, so that's an example of compounded interest. All right, a couple other things they ask in that section is what is the APY for inflation or for an interest rate? So you might not know what that stands for, annual percentage yield. So if I'm going to borrow some money, for instance, and it says our loan is 4.3% annual rate compounded monthly. And then it says, what is the APY? So if you call a bank and ask them what their interest rate is, they're going to tell you a number, and then they're going to tell you how frequently it compounds. They might not tell you the APY. It's going to be a little bit higher. And here's how that's done. You do that by pretending you borrow $1 for 1 year. And so now you'll do A is equal to P times 1 plus R over N to the NP. All right. So in this case, we're borrowing $1. The rate is 0.043. We're compounding monthly, so N is 12. Then N is 12, and we're doing it for 1 year. So time is 1. I put that into my calculator. 1 parenthesis 1 plus 0.043 divided by 12, close my parenthesis, to the power of 12 times 1. Well, 12 times 1 is just 12. So I put that in, and I get 1.043857. I wrote a bunch of digits down there. 7. All right, so that's a bunch. I'm just going to use these right here. Ignore the 1 because that's how much you saved. And you can see that if I do that, that's 4.385, or almost actually 4.386, is the actual percentage APY. Okay, now a lot of times students goes, wait, what just happened to the 1? I'll tell you. See this 1 year? That was the 1 you presented. You started out with 1 plus the interest rate. So the 1 is still there. This is the interest rate. It's 1 plus the interest rate. So if somebody's just asking you for the interest rate, you ignore the 1 so that you can calculate the actual interest rate. All right, I hope that makes some sense. All right, that's been 13 minutes, so I'm now going to stop this one, and I'm going to do a B version and show you how to do the same thing using an app.